Good morning, kiddos. This is Mr. B. It is Thursday, February 10th, and this is an example of what is due on Monday, the 14th. Today, we only have a half hour of instruction, and we are going to finish off, and hopefully what is a little bit of a review of our Unit 1 from McGraw-Hill, Grade 8 Integrated Science. Specifically, these are definitions that you need to find from the text. Create something similar, write out the definition, take a picture of it, and turn it in via Canvas. Again, due Monday, February 14th. Happy Valentine's Day. To that end, here is what we are looking at. And the first part is that comparative anatomy, they state, as you have observed, there's an experiment, I suppose, where they've laid out a bunch of different spoons and asked you to imagine how the spoons might be related and to use that as a metaphor, I suppose, for evolution. The only problem with that, and the reason why I left it out, is that spoons didn't evolve. They're not organic materials that are living structures that we've have developed over a long period of time. There's something man-made. So it's a cute approach, but not something I supported. So anyway, animals also have similarities, even when they appear very different. Observations of structural and functional similarities and differences in species that do not look alike are possible through comparative anatomy. Comparative anatomy is the study of similarities and differences among structures of living species and fossil species. Now, the next definition for you to be aware of is, what are homologous structures? Humans and birds look different and move in different ways. Humans use their arms for balance and their hands to grasp objects. Birds use their forelimbs as wings for flying. However, the forelimb bones of these species exhibit similar patterns. These are what are referred to as homologous structures, and they are body parts or structures that were inherited by two or more species from a common ancestor. That's what we believe. And what you'll see here in each case is you have the upper arm bone, which is the humerus. You have the radius, which would be, when you look at your forearm, the bone that's at the top related to your thumb. That is the radius, and then the underside is the ulna. See if we can get this back to AF again. There we go. And then, as shown in the figure, homologous structures such as forelimbs of humans, cats, frogs, bats, and birds suggest that these species are related. The more similar two structures are to each other, the more likely it is that the species have evolved from a recent common ancestor. And then next, and this is all purely from your workbook. Analogous structures, both wings, shown to the right, are used for flight, but bird wings are covered with feathers. Fly wings are covered with tiny hairs. Body parts that perform a similar function but differ in structure are analogous structures. Analogous structures evolved separately from one another, and organisms with the structures do not share a closely related common ancestor. Differences in the structure of bird and fly wings indicate that birds and flies are not closely related. These are adaptations to our environment for survival, and they are similar structures, right? But they don't have a common origin. At least we don't believe a recent origin in the context of geologic time, practically. The last definition for you to make sure you produce, due by Monday again, is our vestigial structures. The flightless cormorant in the photo has short, stubby wings. Yet, as its name suggests, it cannot fly. It's like penguins can't fly. The bird's wings are an example of vestigial structures. Vestigial structures are body parts that have lost their original function through evolution. The best explanation for vestigial structures is that the species with a vestigial structure is related to an ancestral species that used the structure for a specific purpose. The flightless cormorant, for example, evolved in an isolated ecosystem, the Galapagos Islands, and that did not have any predators or land. Without the threat of predators, the species had no need to fly. Eventually, the flightless cormorant lost its ability to fly due to a wing size that is far too small to support a bird of its proportions. Now again, what we're doing here is another word, and I'm not going to have you write it down, but it's anthropomorphizing, which is when we say that a species, for example, chose to do something, that because there weren't any predators, without this species had no need to fly, the flightless cormorant lost this idea that it chose to do these things is a little bit of a stretch. So it's again, the time frames that we're talking about here are almost geological. In fact, they are. They're big pieces of time. So that's the challenge, obviously, with evolution, is we have a hard time being able to really grasp time in such a large degree. Again, this is the extent of your lecture for Thursday the 10th, since we have a reduced class period. The balance of the time today is for you to complete this work, and if you'd like, turn it in early. Thank you much.